Okay, so hello everyone. My name is Kunal, and I am your mathematics tutor. And actually, we are doing definite integration, and today is our lecture number 4. And in today's class, we are gonna discuss some property of definite integration, which is very important to solve the complex looking integrand indefinite. So today is our basically property of definite integration part, and we actually learn how to implement those property in integration, and we look some problem in it. And so let's begin our today's lecture. So first we are gonna learn a property. These are important, so try to focus more on it. So our property one, this is also known as King's rule. Okay, so it it tells us like if we integrate a function from a to b, this is same as if we integrate this function a to b, but we replace x by a plus b of minus x and dx. What it actually explain? It explain if we integrate a function fx dx from a to b, which is same as if we integrate this function by replacing x to, what we do here, we just replace x by a plus b minus x. And the a and b are the upper and the lower limit of the given integrand. So we can also write it as like its second case, if let us suppose a is equal to 0 here and b is equal to a. That means our given integrand is 0 to a according to this condition fx dx. So when we apply King's rule here, let me write it about the okay. So when we applying King's rule here, we are gonna look its proof too. So let's wait for some time and try to learn how I implement the King's rule in any kind of function. So when we apply the King's rule here, what we get? We get integration of f of a minus x dx, and we are integrating from 0 to a. So this is our form. So if you look at here, what I do, I just replace x by a plus 0 minus x. That means sum of upper and lower limit minus x. What I do here, I just replace x by sum of, this is our lower limit, this is our upper limit, and the so what I do, I just replace x by sum of upper and lower limit minus x. So let's go through its proof, how to prove it. So if we go to King's rule proof, so it's similar to like our given integrand is fx dx. We are integrating from a to b, right? So what you have to do here, let x is equal to a plus b minus t, right? Let us suppose we are substituting here, right? We substituting the value of x as a plus b minus t. So what we get, differentiate here with respect to x. So we get minus of dt because a and b are constant here, right? A and b are constant here. So just I differentiate this equation. So we get a plus b minus t, and we get dx is equal to minus dt. So now, and now on limit, uh, let me write it in now when we look into limit variation, because first we integrate in term of dx. Now I gonna integrate in terms of dt because I substitute the value of x as a plus b minus of some t, where t is variable, right? T is some kind of variable. So now our elementary element changes. My new elementary element is dt. So I have to apply the limit variation and observe how our limit varies. So when x is equal to a, so it will be like a is equal to a plus b minus t. So our t is equal to b, right? So when x is equal to a implies t is equal to b. This is my first case. Now, when x is equal to b, b is equal to a plus b minus t, imply t is equal to a. When x is equal to b, imply t is equal to a. So our new integrand look like something I is equal to, when x is equal to a, our t is equal to b. So I have to integrate from b to a, because when x is b, our t is a. And f of a plus b minus t dt. I hope you'll all understand this, what I'm trying to say, right? Um, Minus of dt here, because dx is equal to minus of dt. And we actually read a property in lecture number 1, which is also equal to like fx dx a to b is equal to minus of fx dx b to a, right? We just interchange the uh, limits, like upper limit become lower limit and lower limit become upper limit. So they come a minus sign. So same thing I apply here. So we can transfer this minus sign. So we can inverse the limits given. So we get a to b f of a plus b minus t dt. And we can replace t is also a variable. So we can replace t to x. No worry, right? We can substitute t is equal to x. Na? So what we get here, we get f from a to b, f of a plus b minus x dx. So we can say that integration of fx dx from a to b is as equal to integration of f of a plus b. I mean, sum of upper limit and lower limit minus x is equal. So this is our basic King's rule, which we proved. I hope you'll all understand this, what I am doing here, right? So now let's move on to the some problem to see how can I apply this King's rule here. So this is the important thing, actually important property basically, like how to apply the King's rule in uh, given integrand. So let's move on. And this is our question number 1. Now I learned King's rule. I teach you the King's rule. Now you have to learn how to implement in a given integrand. So let's take an integrand. So our integrand look like uh, we have to integrand like 2 to 3 root under 5 minus x divided by root x plus root under 5 minus x dx. Look, we have to integrate this, right? So let's try to apply here, like our fx. Our fx is look like root under 5 minus x root under x plus root under 5 minus x, right? This is my fx. So what I have to do when I apply King's rule here, what it said, fx is equal to integration from 2 to 3 is equal to f of 2 plus 3 minus x dx from 2 to 3. That implies from 2 to 3 f of 5 minus x dx. I hope you'll all understand this, what I'm trying to say. So what you have to do, you have to just replace x by 5 minus x. Okay. Okay. So just do that. So our integrand look like we are integrating from 2 to 3, 5. We have to replace x by 5 minus x. 5 minus x divided by root under 5 minus x plus 5 minus 5 minus x. When we simplify it, what we get? From 2 to 3, x root x by root under 5 minus x plus root x. Now, if I add this integration, which is 1, and this integration 2, which is both are equal. So like I plus I, if I do, what I get, we are integrating from 2 to 3, root under 5 minus x by root under x plus root under 5 minus x, plus we are integrating same function, but in different form. We can write into this form, right? And by applying this property of our first class, we can take it into 1. So will we get root under x plus root under 5 minus x. There I miss dx here. 5 minus x, and we'll get root under 5 minus x plus root x. What you observe here, our numerator and denominator get cancelled. Our integration, there 2y is equal to, we have to integrate 2 to 3 dx. So when we do that, we get x from 2 to 3, and when we put the limit in it, insert the limit in it, we get 3 minus 2. So our I is equal to 1 by 2. This is how I implement the King's rule here. I hope you'll all understand what I'm trying to say. Uh, let me tell you first what I do. This is my given integrand, and I just apply the King's rule here. So what I have to do in King's rule, we have to replace x by, if you look at here, what I do here, I just replace here. What I do, I just replace x by a plus b of minus x. So I just, same thing I do here. I just replace x by 2 plus 3 minus x, and I substitute there. So we get something like root x by root under 5 minus x plus root x. And both are same. So what if I add the both integrands? So we get the 2y, and we have to find the value of I. So we get the following value. I hope you'll all understand this. Now let's move on to this second problem. जिसमें चीजें और भी clear हो रही होंगी. So let me write that question. So our question look like integration of, let me take that. And we have to integrate from a to b fx f of x plus f of a plus b minus x dx. I hope you'll all first try that question, then I have to answer. So if you want to solve this question, pause the video and solve it. So what I have to do, this is our given integrand, which is I is equal to fx by fx plus f of a plus b minus x. So what I have to do, I have to just apply the King's rule here. When I applying King's rule here, what I get, I have to just replace x by a plus upper limit plus lower limit minus x. So when I do what I get here, we have to integrate from a to b. I have to replace x by a plus b minus x, upper limit plus lower limit minus x. Same thing, f of a plus b minus x, and plus f of a plus b, and we have to replace x by a plus b minus x. So what I get here, actually I get here is we are integrating from a to b f of a plus b minus x divided by f of a plus b minus x plus f of x. If you simplify it, you get the value of x. Now what you have to do, just add equation 1 and 2. This is our equation 2. This is our equation number 1. When we add equation 1 and 2, we have to integrate from a to b fx dx f of a plus b minus x plus f of x plus a to b f of a plus b minus x dx divided by fx plus f of a plus b minus x. And when we add this both, what we get, a to b dx, right? So what we get our integrand, when we solve this, we get x from a to b, and when we insert that limit in it, we get b minus a. So we get I is equal to half of b minus a. So this is our final answer. So I hope you'll all understand this. What I just do, I just substitute the or replace x by a plus b of minus x. And this is the King's rule. See how it's easy to solve this problem, right? It's just a two-liner problem, one line and two line. What do you have to do? Just replace x by f of a plus b minus x and then add the both equations. Sometimes we have to add and sometimes we have to not. So we also see that case too. So let me take the another example in it. Let's move on to the next example. Let's start the next question. So our next question look like something. Let's take some trigonometric function here. Okay, so our next function is something look like, take that question with the mix. Third question will be, I have to integrate from minus pi to pi x sine x divided by 1 plus 5 to the power x. Look at this problem. There is an x is an algebraic function, sine x is trigonometric function, and in denominator there is exponential function, right? So if you are gonna use our indefinite integration, the things that we learned there, तो यहाँ पे कैसे इसको इंटीग्रेट करना, दैट्स सेम टर्म, राइट? लाइक क्या लगाओगे यहाँ पे लाइक जो भी हमने टेक्निक पढ़ा था, सब्स्टिट्यूशन कुछ कर नहीं सकते बिकॉज एक्सपोनेंट इन्वॉल्व है, बाय पार्ट्स लगा नहीं सकते, बाय पार्ट्स में भी लगा सकते हैं बट वो आई गेस और कॉम्प्लिकेटेड हो जाएगा बिकॉज प्रोडक्ट के फॉर्म है ना, लाइक x into sin x, तो वी कैन अप्लाई, बट in denominator there is a exponential function, so वो भी सोचना पड़ेगा कि by parts कैसे लगाएं. Third things we learn the partial fraction, तो partial fraction से भी ऐसा कुछ नहीं लग रहा क्योंकि ये p by q के फॉर्म में नहीं है because it's not the improper fraction और proper fraction, इसको अपन कन्वर्ट करके लगा सकते हैं. तो पार्शियल फ्रैक्शन वाली टेक्निक भी फेल हो गई, जितने भी स्टैंडर्ड फॉर्मेट पढ़े थे वो भी अप्लाई नहीं हो रहा. तो कैसे इसको इंटीग्रेट करनी है? तो इफ वी थिंक लाइक लेट्स अप्लाई किंग्स रूल हियर. किंग्स रूल इज वेरी efficient to solve the complex looking integrand जिसे हम indefinite integration से solve नहीं करा जा सकता है. मतलब solve तो हो ही जाएगा somehow but वो काफी बड़ा जाएगा. You can easily solve with this King's rule. I hope you'll all understand what I'm trying to say is. So let's apply King's rule here. Let's apply King's rule here. So when you apply the King's rule here, what you get actually, this is minus pi. Let me write it clearly. So our lower limit is pi, upper limit minus pi, and upper limit is pi. When we apply the King's rule, what I have to do, I have to just replace x by upper limit minus upper limit by lower limit minus 1. So if we do so, upper limit minus upper limit plus lower limit minus x, right? Oh my God. What I get? I have to just replace x by minus x, right? We have to do a plus b of minus x. That means sum of upper limit and lower limit minus x. What is King's rule? This is, and when we do so, we have to just replace x by minus x. So this is our I. So our I also look like if we replace, we have to integrate from minus pi to pi, and I have to replace x by minus x. So it will be like minus x sine of minus x 1 plus 5 to the power minus x. Okay. And you know that sine of minus x is minus sine x. This is the basic trigonometric property. I hope you'll know that. So minus pi to pi, what we get when we solve this? So we'll get x sine x. And when we solve the denominator, we get 1 plus 1 by 5 to the power x. So we'll be like x sine x 5 to the power x divided by 5 to the power x plus 1, right? So this is my second form. Both are same, right? So add 1 and 2, right? This as equation number 1. And let me write it here, minus pi to pi dx. This is our equation number 2. So if we add equation 1 and 2. When we add that, what we get? 2y is equal to integrating from minus pi to pi and x sine x by 5 to the power x plus 1 and plus minus pi to pi 5 to the power x dot x sine x by 5 to the power x plus 1 dx. I hope you'll all understand this, what I'm doing. And when we add this, what I get, we have to integrate 2y minus pi to pi. And when we take x sine x common, what we get here? 5 to the power x plus 1, whereby 5 to the power x plus 1. Oh my God, this get cancelled, right? Our work somehow get easy. So our 2y is equal to minus pi to pi x sine x. Now this can be solved as by the technique of by parts, right? So let's apply by parts here. So what we get, we have to apply the eyelet rule, which we already know. Apply the by parts here. So let's apply it. So what we get, this is our u function, this is our v function, right? Now I have to do 2y is equal to what is this is our by parts, u v minus du v dx. So this is for recall you. This is our by parts formula. So it will look like minus pi to pi. I have to integrate. We take first 2 outside. And what is the integration of sin x? It will like minus cos x. And minus, I have to differentiate the x. So we get 1. And again, we have to get minus cos x dx. So 2y is equal to minus pi to pi minus x cos x plus there will be like sin x, right? There will be like sin x. So it's something look like, let me write it here in a good way. It's not the good way to write it. Okay. It will be like minus pi to pi and sin x will be like minus pi to pi. So when we substitute here, what we get actually, put the values here, right? So what is the value of cos pi? Cos pi is minus 1. So we'll get pi. And what is the value of it's again, we'll get pi. And sine pi is 0, sine minus pi is 0. So we get nothing from here. Like 2 pi is equal to 2y. So our integrand value is nothing but pi. So this is our final solution, right? I hope you'll all understand this, what I'm trying to say. So this is actually King's rule value, right? This looks like our integrand consists of 3 functions: algebraic, trigonometric, exponential. And what I just do, I just apply the King's rule here and it solve in a quick way. I have to do something like I have to apply by parts as well, but it's mostly it's simplify our integrand. It looks some favorable to us as I read it in indefinite integration, right? Now let's move on to the standard example, which is ln 1 plus tan x. This is actually the most important question of today's class. One of the most important to actually sabhi hai. So let's move on to the next problem, which is I just show you how to implement the King's rule, right? Because implementation is the things that we have to learn in calculus. Because theory तो कहीं से ही पढ़ लोगे ना, but how to implement in different kind of problem, this is the thing that you have to learn. How to implement in tough problem, how to implement in easy problem, right? So let's move on to the next problem. Example number whatever star, let's call it star. Okay, so our problem look like we have to integrate from 0 to pi by 4 and log of 1 plus tan x dx. Let me set like tan x dx. Now, what you have to do here is you have to find the integration. So what I just learn the King's rule. So apply King's rule here. So when I apply the King's rule here, what I get, when we replace x by pi by 4 minus x, because a plus b minus x is same. So we have to replace x by pi by 4 minus x. So our this is our integrand, right? So our new integrand will look like we have to integrate it from 0 to pi by 4. What I get? ln 1 plus tan of pi by 4 minus x. Because I have to replace x by pi by 4 minus x. And you know one thing, the tan of a minus b formula. If not, then no worry. Let me write here. Tan a minus tan b by 1 plus tan a tan b. So this is the formula of tan of a minus b. Right. Let's apply this formula here, trigonometric formula. So what I get, we have to integrate it from 0 to pi by 4 log of 1 plus tan of, let substitute a is here and b is this. So tan of pi by 4 minus tan of x divided by 1 plus tan of pi by 4 and tan of x dx. And you all know that what is the value of tan pi by 4? This is 1. So we have to integrate from 0 to pi by 4 ln 1 plus 1 minus tan x divided by 1 plus tan x dx, right? When we simplify this, what we get? We get actually 1 by 1 plus tan x, 1 plus tan x plus 1 minus tan x, right? What we get? I get 0 to pi by 4 ln 2 by 1 plus tan x. So when I apply the basic logarithmic property here, so what I get I is equal to 0 to pi by 4 uh, log of 2 minus log of 1 plus tan x dx, right? And this is constant, obviously. So what we get when we integrate this, we get ln 2x from 0 to pi by 4 and minus integration of 0 to pi by 4 ln 1 plus tan x dx, right? And this is our nothing but I. If you notice that this has to be, we have to integrate. Like what we can write, take it left hand side, we get 2I is equal to ln 2 and put the value here. Insert the limit, upper limit and the lower limit. So we get pi by 4. So the our I is pi by 8 ln 2. This is the problem that you have to solve. I hope you'll all understand this. We have to apply some trigonometric formula here, like tan of a minus b and just applying the King's rule, right? So this make life simpler and it will also very helpful in solving tough problems. So let's move on to the next problem actually, and then we look our Quinn's rule. What Quinn's rule and its proof as well, right? Like how to prove the Quinn's rule that we have to learn. So in today's lecture, we are going to learn two rules of definite integration, which is King's rule and another one is Quinn's rule. So let us take one more example and then we move to the Quinn's rule. Okay. So our example is something. Okay. Let's solve this problem. This is the very important question of today's lecture. This is very important. So what is given? Let you have to think actually case by this problem. So first I have to write the problem here. Let fx is equal to, I have to integrate from 0 to 5 mod of t minus x here given and dt. Then you have to find fx. Let me erase it and write it in a clear way. Then you have to find fx. Then find fx. You have to find fx. Now, look at this question, right? What this question tells you. First, try to understand what is mod and what mods tell you. So, the function of mod is like, uh, it gives the positive return always. Whatever you write inside it, it will give you a positive value. Like if you put x, so it will get x is positive. So it will give you the x, and if x is negative and you put in it, so it will be get minus of x. So that x is positive, right? So this is the basic property of the mod. So we have to look the property of mod and how to approach this question. So let us think here. We have to integrate it from 0 to 5, right? So what if, let's take the case here. Case 1, right? What if our x value greater than is equal to 5? Like, what if the x value is like 6, 7, or 8? And whatever we get the integration, we have to substitute in t because our elementary element is dt, right? So it is negative. Then when x is greater than 5, then our fx is equal to, we have to integrate it from 0 to 5 x minus t dt. I hope you'll all understand why x minus t, because this uh, on the value inside the mod becomes negative, so it comes out with the negative sign, right? Actually, I am applying this. Let me write it here. I am nothing but applying this. The value inside the mod is negative, so it comes out with the negative sign. So same thing, when it comes out with the negative sign, so minus of t minus x will be like x minus t, right? I hope you'll all understand what I'm trying to say. Let's move on to the, so when we integrate this, what we get actually, uh, we get, try to integrate with respect to t. So xt minus t square by 2, and we have to insert the limit. So we get 5x minus 25 by 2. So this is our first case answer. What if, the second case is, what if uh, x is less than is equal to 0? Because our lower limit of t is 0, right? So what if our x value is less than 0? That means negative value or equal to 0. So there will be positive. So then fx will be look like positive. So we have to just integrate 0 to 5 and t minus x dt. So what we get? We get t square by 2 minus xt, and we have to integrate the 0 to 5. So what we get? 25 by 2 minus 5x. So this is our case 2. Now the third case is, what if our value of x lies between 0 and 5? How can you decide that it is positive or negative? I'm saying कि if the value greater than 5, so ये दिख रहा है कि हाँ ये negative है. The value inside the mod is negative. If the value is less than 0, so ये minus minus plus हो जाएगा. So it seems like ये positive है. But what if the values lies between 0 and 5? How can you decide that? So what I have to do here, I have to do some manipulation here. Then uh, fx will be written as like 0 to 5. I have to integrate t minus x dt mod. So it will be equal to, like, we have to first integrate from 0 to x. So in 0 to x, it seems like negative. So I have to write x minus t dt. And in x to 5, it is positive. So it will be like t minus x dt. And now integrate it. So you get the very result, which is like t square by 2. And I have to integrate it from 0 to x plus t square by 2 minus xt from x is equal to from x to 5. Right. So when I when I insert the limit in it, so what we get? We get x square, because I have to insert x in it, and x square by 2 plus 25 by 2, 25 by 2 minus 5x plus x square by 2 and minus x square. I hope you'll all understand this, what I'm trying to say. So x square get cancelled, x square by 2 get cancelled. And what we get here, we receive the result like 25 by 2 minus, actually 5x minus 25 by 2. I do some mistake here. So let me clear here. X square, I missed something, right? Oh yeah, there is some positive x square. So we actually get what I get. There x square by 2 get cancelled, and there is negative. Oh, I do simple mistake here, and plus minus sign. Okay. So x square minus x square by 2. So there will be like minus x square by 2 and plus x square. So we get 25 by 2 minus 5x plus x square. So what we get, actually the final integrand, we get the three values. First, when the x is less than 0, so what we get? Look at here. When x is less than 0, we get 25 by 2 minus 5x. So it will be like 25 by 2 minus 5x. And when x value varies from 0 to 5, so we can write it into as x square minus 5x plus 25 by 2. And when x value greater than 5, what we get? X value greater than 5. Look at here. 5x minus 25 by 2. 5x minus 25 by 2. So this is the problem when mod is involved. So we have to look actually in a case wise, right? Okay, so you have to look into it very carefully. Now let's move on to the our today's property, last property, which is actually nothing but a Queen's rule. You see, it is also important. So property number 2, this is known as Queen's rule. Today we learn King's and Queen's rule. What Queen's rule state? So Queen's rule actually states that, let me write it first and then I explain you. It explains that if we're integrating a function from 0 to some 2a fx dx, then it is equal to 0 to a f of x plus f of 2a minus x dx, right? And it is equal to like 2 into 0 to a f of x dx if f of 2a minus x is equal to f of x, and equal to 0 if f of 2a minus x is equal to minus of fx. So this is actually Queen's rule. I hope you'll all understand that what I'm trying to say. Let's this is our basic things that I have to apply it. And now first, what did it state? So if I integrate a function with respect to x from 0 to 2a or anything, like let me clarify what I'm trying to say. Like you can say that if we are integrating from 0 to a. So what I have to do here, I have to write this fx as fx plus f of a minus x dx and just half do the half of the limit. So it will be 0 to a by 2 and it will be equal to like 2 from 0 to a by 2 fx dx agar both are equal, and if both are equal with opposite signs, it will get 0. So let me show it's let me show you like its proof, then you understand this. So you just read the King's rule, right? What King's rule explain? X replace x by upper sum of upper limit plus lower limit minus x. So the same thing if I do here in 0 to 2a in given function f of x dx, right? So what I get, let me show you. Uh, this is our I. So our new I look like apply King's rule here. So we have to replace x by 2a minus x, right? So it will be like uh, what I'm trying to say, f of 2a minus x dx. So our limit also changes. So we have to see the limit variation, actually replace it by limit variation also. So when x is 0, when x is 0, uh, like it will be same, right? Now add the both of the equation. So what we get, 2y is equal to 0 to 2a f of x plus 0 to 2a f of 2a minus x dx, right? So when we do that, we get I is equal to 0, 2y is equal to 0 to 2a f of x plus f of 2a minus x dx, right? So actually when we proceed on, so what we get, we can half the limit. Like if we do the same calculation, insert the same thing in it and half. Look, what I'm trying to say is there is two ways to write this. Either you can substitute x as 1 by 2, or we can find the value of x and then do 1 by 2. Both were same. Like, look, what I'm trying to say, like there is correlated, right? 4 plus 1. Okay. So either you can multiply it by here by 1 by 2, or you can solve this 4 plus 1 and then multiply by 2. Both were same. What I'm trying to say, it will be 0 to a f of x plus f of 2a minus x dx. And when the both were same, it will be counted as our I is equal to 0 to a 2 times of f of x, or when it is when fx is equal to f of 2a minus x. And when fx not equal to, like fx is equal to minus of fx is equal to f of 2a minus x, So it will be something look like I is equal to 0. So you can write directly I is equal to 0. So what you have to do, you have to first check कहीं f of 2a minus x is equal to minus of fx तो नहीं है. तो our integration value is directly counted as 0. Nothing to do, no calculation. तो sometimes क्या होती है एग्जाम वगैरह में जानबूझ करके प्रॉब्लम को बढ़ा देते हैं लोग, ठीक है. एंड फाइनली लास्ट में लोग सॉल्व करने लगते हैं बिना सोचे, किंग्स लगाने लगते हैं, क्वींस लगाने लगते हैं, वॉट एवर दे वांट. बट यू लाइक बाय पार्ट सोचने लगते हैं, कुछ तो सोचने लगते हैं, बट यू हैव टू फर्स्ट ट्राई टू चेक. लेट मी सपोज अगर एफ ऑफ 2a माइनस एक्स इज इक्वल टू एफ ऑफ माइनस एफ ऑफ एक्स आ गया, तो उतना जो बड़ा सा मसाला दिया हुआ उसकी डायरेक्टली आंसर कितनी हो जाएगी, 0 हो जाएगी ना. You don't have to solve actually that question. What I'm trying to say, I hope you'll all try to connect me. So first, try to check your condition. Is it applicable for king's rule? Is it applicable for queen's rule? And then apply the king's and queen's rule. Okay, so you can apply it like some problem, like कुछ problem ऐसा भी होंगे जिसमें हमें साथ में किंग्स भी लगाना होगा. हो सकता है एक से ज्यादा बारी किंग्स लगाना हो. लाइक अभी तक जितने हमने प्रॉब्लम सॉल्व करी हैं, मैंने किंग्स रूल को इम्प्लीमेंट करना बताया, तो उसमें हम लोगों ने क्या करा कि एक बार किंग्स लगाया एंड देन वी जस्ट ऐड एंड वी गेट द रिजल्ट. समटाइम्स प्रॉब्लम में क्या हुआ कि एक बार किंग्स लगाया, फिर दूसरी बारी भी किंग्स लगाने की जरूरत हो सकती है, या फिर क्या हो सकता है कि एक बार किंग्स लगाया, दूसरी बारी क्वींस लगाना पड़ गया. तो इट विल बी लाइक एक प्रोसेस है कि तुम्हें सोचना होगा कि कब हमें क्या लगानी है, ठीक है. तो यू हैव टू थिंक अबाउट दैट. तो दिस इज आवर क्वींस रूल, जो कि बहुत ही ज्यादा यूजफुल है फॉर complex integral, and it is basically derived from King's rule. So nothing to worry about. And so what I have to do, I have to just show you how to implement the Queen's rule in any problem. So let me write a simple problem here, and then we discuss tomorrow's a more problem with combination of kings and queens, and discuss some more property as same as kings and queen, which make your definite integration easier. So let us move to the today's example, which is like 0 to pi by pi. And I have to integrate from like sine to the power, let us suppose cube x. Yes, I have to integrate this, right? So let's apply the queens here. So our fx is sine cube x, right? I know you know that in indefinite integration, how we integrate this. Either we are applying here कितने तरीके थे, या पहला तो था बाय पार्ट्स, दूसरा था लाइक ऑड पावर है, सो वी अप्लाई द cos x as t and then we proceed. तीसरा था by trigonometric identity, like we know that sin 3x is equal to 3 sin x minus 4 sin cube x. तो यहाँ से sin cube x को ले आते थे सॉल्व करके, एंड देन इन दोनों को इंटीग्रेट कर देते. बट देखो क्वीन से ये सब कुछ करने की जरूरत नहीं है. जस्ट अप्लाई द क्वींस रूल एज अकॉर्डिंग टू व्हाट इट स्टेट. सो वी नो दैट fx dx 0 to 2a is equal to f of x plus f of 2a minus x 0 to a dx. So let's try to implement it. So our fx is sin qx. So we can write it as 0 to pi by 2, right? Half of the, this is our 2a, right? So half of pi is pi by 2. And there will be like sine cube x plus, when we do like sine cube pi minus x, right? Sine cube pi minus x. What is sine pi minus x? It is sine x. So we can write like sine 2 sine cube x dx is from 0 to pi by 2. You see that like we get two value if both were same. Now apply Wallis formula here. What is Wallis formula? We have to integrate from 0 to pi by 2 any sine to the power n x, right? And their n value is 3. We can apply reduction formula as well, but Wallis is fair enough. So it will be like 2 to 0 to pi by 2 And when we integrate this function, what we get directly, oh, I'm applying Wallis now. Let me read what I'm doing here. Okay. So so I have to write 3 and we have to subtract it -1 and then we have to just go through it. And since the power is odd, so we have to multiply it here by 1. So what we get? 4 by 3. See, it's a two-liner problem, right? This is the statement that I tell you like what the Queen's law states. So this doesn't count in our solution. You have to think it. This is in mind. मतलब वो अभी लिख दिया ऐसे क्योंकि तुम्हें लाइक कैसे इम्प्लीमेंट करनी है ना वो मैं बस दिखा रहा स्टार्टिंग में ऐसे इम्प्लीमेंट करना एंड देन तो ये सब तो दिमाग में चलना चाहिए ठीक है जब जब और भी ज्यादा वो प्रैक्टिस कर लोगे ना तो ये तो देखते ही इसके आंसर बोलोगे 4/3 ऐसा ठीक है nothing to worry about. So this is the way like how to implement the Queen's rule and we use some small topics like volley जो मैंने second lecture में cover कर रखा है already. So अगर समझने में दिक्कत हो रही है so you can go through to the lecture number 2 and check it. I hope you'll all understand this what I'm trying to say. So let's move on to the oh I think it's time over. Okay, so in next class we discuss some problem based on composition of kings and queens rule, in which in one step we apply king's rule, in next step we apply queen's rule somehow, and this is in next class we discuss some problem based on composition of kings and queens rule, and we discuss some more thing like more property to make our definite integration easy, as easy as possible. It is actually easy. Nothing to worry about much. मतलब आसानी है कुछ करना नहीं होता बस थोड़ी सी लॉजिक लगानी होती है कि कब क्या करना होता है दैट्स इट अदरवाइज बाकी तो बस पेन ही चलानी है इसमें यू हैव नथिंग टू डू हियर ओके सो थैंक यू वेरी मच